Alright, so today I bought an energy drink, a little. So I'm gonna try to spend at least 7 hours here today. I'll put the alarm thing here. Because I bought this energy drink, because I wanted to. It's been a long time since I don't drink anything that has caffeine. And I wanted a motivation boost. I don't think it's good to drink caffeine or other energy drinks because you increase temporarily and in the moment your energy levels, but overall in the long term it decreases. So, if you do it in a way that's not that frequent, then it can be good. So currently I'm doing something that was recommended by Andrew Huberman, which is a guy that has a YouTube channel. Oh, look here. I'll show the podcast that I saw. I think I'm subscribed to him on the other browser, my other channel. This channel I just keep for coding stuff, but yeah, this one. I think was the best podcast I've seen from him so far. And it's really good.
Is separate from my teaching.
Maybe I'll watch this while I eat something before I start studying the stuff. I think I'm also gonna put some video of people studying for 7 hours in case the alarm clock fails. So I can see how much time I spent here. I'm gonna try to spend 7 hours, which is probably gonna be hard for me because usually after the 2 hour mark, I'm already tired and starting to lose focus. So I'm not sure if I'm gonna take any breaks in between. Study session 7 hours. And then hopefully I can go even beyond 7 hours. But my goal is gonna be to figure out how to create the library dependencies. The graphical representation of library dependencies. So I can study the sklearn library later using that. So basically in this podcast, if I don't go over everything, which I probably won't, it talks about that if you do something that is challenging very frequently, you shouldn't have dopamine rewards every time, because that's gonna jack up your dopamine reward system. And you shouldn't reward yourself every time after you do the task, because if you do that, your brain starts hating the task itself because it's always waiting for the reward later. And the best way to do it, if I got it right, and I'm not sure if that's what he meant, but if I understood what he meant, is that the best way to do it is you randomize your dopamine rewards for tasks that are challenging and do it very frequently. So I'm using a randomizer to do this. Every morning I wake up and I roll the Google randomizer 3 times, and if I get lower than 50, then it's a high dopamine day, and if I get over 50, then it's a low dopamine day. And so far it has been working really well, I find, because it keeps our brain in check. It helps your motivation.
I'd like to announce that there's an event that some of you may find very useful. This is an event put on by Logitech that I will be speaking at.
So yeah, today is a high dopamine day. And because I haven't drink coffee on my my high dopamine days for some time now, I think it will be good to do it now, so I have the motivation boost, and then I can work. Hopefully I can work for more hours today, study more, focus more.
So let's talk about dopamine. Most people have heard of dopamine, and we hear all the time now about dopamine hits. But actually, there's no such thing as a dopamine hit. And actually, the way that your body uses dopamine is to have a baseline level of dopamine, meaning an amount of dopamine that's circulating in your brain and body all the time. And that turns out to be important for how you feel generally, whether or not you're in a good mood, motivated, etc. And you also can experience peaks in dopamine above baseline. Now, this has a very specific name in the neurobiology literature. so-called tonic and phasic release of dopamine. And I'll explain what that means in a couple of minutes. But if you remember nothing else from this episode, please remember this, that when you experience something or you crave something really desirable, really exciting to you, very pleasurable, what happens afterwards is your baseline level of dopamine drops. Okay, so these peaks in dopamine, they influence how much dopamine will generally be circulating afterward. And you might think, oh, a big peak in dopamine, after that, I'm going to feel even better because I just had this great event. Not the case. What actually happens is that your baseline level of dopamine drops. And I will explain the precise mechanism for that. Okay, in the neuroscience literature, we refer to this as tonic and phasic release of dopamine. Tonic being the low-level baseline that's always there circulating, released into your brain all the time. And then phasic, these peaks that ride above that baseline. And those two things interact. And this is really important. I'm going to teach you the underlying neurobiology, but even if you have no background in biology, I promise to make it all clear. I'll explain the terms and what they mean. And I'm excited to teach you about dopamine because dopamine has everything to do with how you feel right now as you're listening to this. It has everything to do with how you will feel an hour from now. It has everything to do with your level of motivation and your level of desire and your willingness to push through effort. If ever you've interacted with somebody who just doesn't seem to have any drive, they've given up, or if you've interacted with somebody who seems to have endless drive and energy, what you are looking at there in those two circumstances is, without question, a difference in the level of dopamine circulating in their system. There will be other factors too, but the level of dopamine is the primary determinant of how motivated we are, how excited we are, how outward-facing we are, and how willing we are to lean into life and pursue things. Dopamine is what we call a neuromodulator. Neuromodulators are different than neurotransmitters. Neurotransmitters are involved in the dialogue between neurons, nerve cells, and neurotransmitters tend to mediate local communication. Just imagine two people talking to one another at a concert. That communication between them is analogous to the communication carried out by neurotransmitters, whereas neuromodulators influence the communication of many neurons. Imagine a bunch of people dancing where it's a coordinated dance involving 10 or 20 or hundreds of people. Neuromodulators are coordinating that dance. In the nervous system, what this means is that dopamine release changes the probability that certain neural circuits will be active and that other neural circuits will be inactive. Okay, so it modulates a bunch of things all at once. And that's why it's so powerful at shifting not just our levels of energy, but also our mindset, also our feelings of whether or not we can or cannot accomplish something. So how does dopamine work and what does it do? Well, first of all, it is not just responsible for pleasure. It is responsible for motivation and drive, primarily at the psychological level. Also for craving. Those three things are sort of the same, motivation, drive, and craving. It also controls time perception. And we will get deep into how dopamine can modulate time perception and how important it is that everybody be able to access increases in dopamine at different time scales. This turns out to be important to not end up addicted to substances, but it also turns out to be very important to sustain effort and be a happy person over long periods of time, which I think most everybody wants.
I'm going to pause here. I'm going to figure out how to do this graph this stuff. Tried adding in a path on the both paths, but it didn't work. It's still giving me this error. Attribute error, module graph this, dot backend has no attribute encoding. So I think I'm gonna search this to see if I find anything on Stack Overflow or other sites. Similar issue when using pip-dep3, it would seem that there was a very recent change to graph this to obfuscate internals. In the short term, you could downgrade your GraphViz module. It looks like 0.18 was the last tag before the submodules were made opaque. Moving forward, you may wish to create an issue and or pull grass against the escalator and pandas repository. Just cap it. Dependency. Yeah, great, but they don't give anything. Not include the version number, but it looks like the line number in the traceback match with v016. Note that the traceback shows error to be inside the Python GraphViz package, so it's more likely that it's an issue of a dependency. I don't get the import error. How can I install a specific version? Use leading case of doubt check the contents of the init file. If I do pip install this or condo install, and then I try again, I'll probably have to add to the path. The path variable also added on side packages, but which was different than the video that the guy was showing, because mine doesn't have anything on the being folder for Anaconda. Maybe if I search for how to install Graphis, it will work. I think I'm gonna do this.
Hi everyone, welcome to the 88th session of Python for Machine Learning. In this session, I'll show you how to install the GraphViz
And
Python
welcome to
Plus and execute it to generate the decision tree graph in Anaconda Spider. I will simply execute the Python code for decision tree classifier, but I'll not explain decision tree. That I'll explain it in the later sessions. So first of all, what we need to do, the steps are as follows. We need to install the GraphViz for Windows. Then we need to set the environment variables, followed by finally installing the Py.Plus Plus in Anaconda prompt. So what I will do, we'll go here and we'll give install GraphViz. You go to here, okay, and then stable 2.38 Windows install package, and then from here you just install this. Now because I've already installed this, so I will pause it and I'll use my existing. We need to, like, it will automatically take, you have to just press the buttons next, it will be installed. So you can close this. Now once this is done, you need to go, like, you need to go to the program variable and like program files, go to Windows, then program data this, and then go to GraphViz, yeah, and then go to bin. You take this full path, control C, okay. Now this PC,
So maybe that's the problem. Maybe I need to do the formal installation instead of using pip install. Hopefully it works. Download. No, but here's just showing X installer. Nice. The system is 64 bits, if I'm correct. So that's probably the reason why I didn't have the bin package there. Conda, lib, side packages, Graphis. Yeah, it doesn't have a bin. So maybe it needs to be formally installed instead. I'm not sure, probably not necessary, but I'm gonna change the screen. Do not add Graphis to the system path. I think this is add Graphis to the system path. And then it's gonna add automatically. Hopefully. It's probably on the other monitor. And there's no Graphis here. Maybe I have to uninstall first, then install again. Graphis here. Hopefully this works. So I need to remove this one. Yeah, this is the correct one, I guess. Then I have to remove this one. Okay. Doesn't work. I'm gonna try to uninstall the ones I have on Conda. Or maybe I can change the file there. So it is on the side packages instead. Maybe that works as well. The issue is that I had to install Conda on the other hard drive of my computer because it has more space. Yeah, no attribute encoding. So I guess I'm gonna try to delete the other one manually. Let's see. No, here it does. No side packages here. So that should be here. The only place that is installed. And then I have to change the path again. Here. Delete this. This one here. Leave. Yeah. I'm gonna take this path here. I'm gonna change the system variables. Oh, it's already here? Now it should work. Here, same thing. I don't know what the... Oh, here's the whole system and here's for only my user. That's the difference there. I'm gonna reinitiate PyCharm just in case. Hopefully it works. If it doesn't work, then I think, yeah, Graph is not gonna find. I'm gonna have to think about how to tell Conda to find the package, the file that I have it. Oh, now I found it. If it doesn't work, I'm gonna uninstall everything and then install again. Well, it didn't work. I'll just specify path to a library, varchar. And custom paths this way. Which file settings project interpreted? Project interpreter field, click the down facing arrow and select show all. The menu highlight your interpreter, and then in the right menu select the bottom show paths for the. So I'm gonna do this in another window. So I can do it the same. Just gonna follow the instructions there. So settings, project interpreter. I can do add the package. The project interpreter field, click the down facing arrow and select show all. So mine doesn't have this. Show all. Now it has. The menu highlights your interpreter, and then the right menu select the button. Show paths for the selected interpreter. This last button, click the plus symbol to add your path. So mine I think is a little bit different. Oh no, I found it. Click the plus sign and add your path. Believe. Side packages. Graph this. Oh, there's no. It doesn't show the Bing. Great. It shows this file only. And it does have a backend here. But maybe if I put graph this, it's gonna work. And now it works. So I'm gonna show what I have done. Let's go File, Settings, Project Interpreter. Click here, Show All, then the Add button here. No, then you click the one you're using, click this one, and then you add. You can see here, added by user. Now apparently, well, but it's not recognizing. Rename a reference. Oh no, that's not it. Maybe if I just add here instead. But then it's gonna install. That's not what I want. Maybe if I install from pip and then put the Bing library inside it. This is the most annoying part of programming. Fucking packages. Can custom paths this way, go to file settings. Yeah, that doesn't work. Other interpreter paths in PyCharm. It's the same thing. Maybe if I delete, I'm gonna delete everything and then I'm gonna try to do the same process but use the C folder instead. Just see if it works. I'm gonna delete this. And I'm gonna exclude both on the path variables. Path, edit, exclude, okay. I'm gonna come here, settings, show all, this one. Oh, it's not here anymore. Nice. I'm gonna close this. Go to my downloads. It's this one. Next, next. So now let's see if it installed. It's here. I'm gonna get this path. Oops. And then I'm gonna try to add this to the PyCharm. See if it works. If this route doesn't work, then I'm gonna have to figure out this is that meta path thing. It's probably gonna be a lot harder because then I'm gonna have to create the graph myself somehow. I'm not really sure how.
Algo trading. Today, I'm going to tell you how to use graphics or the Python code to visualize a decision tree. Open your new Jupyter notebook and let's get started. I am using Python 3.7 and a Jupyter notebook.
So let's try to add this thing. Wow. It doesn't work.
Before that, a little bit about graphics.
Properties, go to advanced system settings, then environment variables. You click, go to this path and click edit, and then add here. I've already added. You can just give new, and then you can give your, okay. So I will, this is how it will be done, okay. Now after this is done, what I will do, this is my code for the decision tree. This is my code for the decision tree classifier. I've already installed GraphViz, and as per this steps, step 1 and step 2 is being achieved. Now we have not installed the py.plus, okay. If we execute this, what error we'll get? Okay, it will say that py.plus is not found. So what we'll do, we'll go to anaconda prompt. So what I will do, I'll give pip install and then py.plus.
Please work.
So if we execute this, so that we have installed py.plus and this is being executed, and our graph is written to iris2.pdf and iris2.png. If we open this, so if we open this, we can see the graph is like has come here. Now if you want to go into the code, it is like it is a normal decision tree, but this dot data is where everything is being handled. Now, dot data is how the data from this is being entered into the graph. So that I'll be showing you the details, how the entropy was, how you get the information about the details about the information gate, the certainty and certainty about the pure.
Not sure what's going on. If I try to install using pip install. Then I'm gonna try to put the bin file into that thing. Not sure that's gonna work. It says it's already installed, but it doesn't work here. Yeah, so I should be finding the one that I have on the C disk, but For some reason, it doesn't recognize in the file. Everybody seems to have the same solution for this. Just a problem. You want to start drinking the energy drink stuff? Installed packages. Downloads, documents. I want to see if there is a new one here, because if there is, then it means that installed a new one instead. It says that it's installed there. It's weird. Work? Doesn't. Maybe if I make a copy and put on the side packages. this shit, man. It doesn't work, so I'm gonna remove everything from the paths there. I'm gonna try to install again. Last time I installed like this, it works. So it worked. Now, apparently it doesn't. Now it shows up here. Great. Now it's gonna give me the other mistake. It worked? Did it work? I'm not sure if it worked or not. Hopefully it did let me. Let me test with the commands there that I want to choose. I think it was here. Yeah, these ones. There's no attribute formats. This is giving me a different mistake than before. Oh, here it is. Parameter formats. Maybe if I put this stuff here on the back end. Let's try again. I'm not sure if it's if I can do that because I don't know if it's the same file or not. Maybe I'm on the wrong graph. No, that should be this one. So let me try now. I think, yeah. Graph is not available but necessary for the output option. Please install it. What the hell? Maybe if I make a copy instead of passing. The way it has on both. It's not gonna work now. I'll be right back. Just realized that it was off. So I'm gonna delete this from here. Great. Nobody responded. Future tools util plot utils plot utils.py. So I guess the problem is not on GraphVis, is on the deep depth tree part. Hmm. Don't understand this solution from this guy. This is really annoying. It does show up here formats, but I think the way that I'm gonna do it is try to figure out how to do pip depth tree on this Python script, get the object, and then try to use graphviz here instead of on the terminal. I'm also gonna exclude this main for now, so it stops printing the libraries that is loading in the beginning. We call pip depth tree here. So I'm gonna search how to use pip depth tree on a Python script. I think this is probably gonna be a more interesting route to take then, try to figure out how to install it in the Dot language, that graph, directed graph source code in the Dot language. Turn data bytes by pass through engine into formats as bytes. That's graph is dot graph. Name optional string graph name used in the source code. Let's put name package lib dependencies. Comment optional, comment added to the first line of the source, file name for saving the source, defaults to name plus .uv. Directory, subdirectory for source, saving and rendering. So these two are not optional. Format optional, string rendering output format. So I'm gonna put file name here. Equals to lib dependencies dependencies. What PNG? Directory for source saving and rendering. Then the format. So I'm gonna try to put format here. We have attribute mapping of attribute value pairs for the graph. Node attribute mapping of attribute value pairs set for all nodes. Edge attribute mapping of attribute value pairs set for all edges. And these ones I'm not sure what I'm gonna put. Lines to the graph body. If I run this, probably not gonna work. God, man. If only this could work. Maybe if I try to save in another format. Didn't try to do that before.
Graphics is a open source libraries that is use your process.files. It looks like this. If you want to know more about Graphics, you can just go through this file, and you can import this graphic from sklearn.tree. Okay, so let's start it here. Let's start here. So first thing, you have to import the data, and I'm using the data as iris data. So if you can see, if you see here, I'm importing the iris data from sklearn dataset. So sklearn has already added a lot of dataset inside it. If you go to here, the official website of scikit-learn, if you see a lot of datasets are here, Boston house price dataset, we are using this iris planet dataset, and diabetes dataset and all right. So I'm just importing that iris dataset to my Jupyter notebook. And if you really want to see how it looks like, so what I did, I just downloaded the dataset into my local drive, and I'm importing, and I'm showing the first 5 row of the dataset to see how it looks like. So I'm just showing it. See, this is how it looks like, this iris dataset, which is there in sklearn. If you want to see here also, you can see this one. Okay, here, this one, the same thing here. So I'm showing it here. You can just check it here. See, sepal length, sepal width, petal length, and petal width. And these 4 is my x variable, and my y variable is species. So then what I need to do, I need to import tree from sklearn, and I'm trying to fit the decision tree classifier with my data, which is my feature, 4 feature, and the target, which is my y variable, right? And the next step is you just import graphics, and then you are creating a variable called dot data, and then we are putting this tree dot export graphics, and then you need to put these hyperparameters. Okay, so and the default is the index. So then you are putting graph equal to graphics dot source dot data. That's it. These 2 line of code will create a graph. Now if you want to see the graph decision tree, how it looks like, just enter, and then I think I have not run this. Okay, I just run it here. So run it, and run it, and now you can see this is how it looks like. Okay, this is a decision tree, it looks like. So it start with petal length, so this one is here. Okay, so now this is how it looks like. So if you ask me why it start with petal length, there is another video I'm going to create, that how you read the decision tree basically. So this is gene index.
I don't think this says what I want. I'm gonna close it. Pip install py.plus. Plus. Module object has no attribute. Graph is on Windows 10. Let's try this one. It doesn't work. Maybe I can create it manually myself. Just go to graphics. Here. Backend. Oh, great, now I can't close this. I think I'm gonna have to restart PyCharm. Goodbye. But the good thing now is that I understand a lot more about these libraries than I did before. When I look at these things now, I can see things that I'm a lot more familiar with than before, which is a good sign. I don't know what typing overload is. I just need to understand the flow of information here, the flow that it runs. Line 194, return one code main globals none. So let's see, 194. There, run code main globals none, main mods back. Run module was main. So it tries this. If author argv or mod different than name. Mod name, spec code, get module, details module name. Else, controls this. Message, this is executable. Author, so this worked because it didn't give me any error. And hit this line here. Author argv, sys.argv0 mod spec dot origin. Then from this, apparently it went to this. Run code, which is on the same file. Then line 7, line 877, output dump graph is 3, output format equals args.output format. So this is only the pip.tree file. If output format not in backend formats, output error module backgraph. So it's in the pip.tree the problem, because it says here. It's not on the graph, it's not a Sparta format output format. So where is it giving me this line here? So graph is dot backend is not a Sparta output format. There's no attribute formats. But it's a different line here. So it's saying PNG is not a Sparta format. I think I'm gonna try to run it with the other formats and see what, if it gives me the same mistake there, same warning. Our Fizz backend has no attribute formats. But the thing is giving me a different mistake. That's what's weird about this. Let's try this one. Doesn't work as well. And now I saw that I changed something here. Oh, it's working. What? Oh, dependencies. Oh, I'll be right back. So I had a couple ideas while I was out there. I think I can close this. Let me try to open this one. Yeah, it doesn't have any information. So I think the problem is on pip-dep3. So what I can try to do is try to output on a JSON format and see if it works. Oops. JSON file extension. If it doesn't work, I'm gonna study the code there and try to figure out what it's doing. I mean, worst case scenario, I'm not able to do this, and then I can just move on and study manually the thing. Anyway, .json, yeah. But I feel like doing this is already really good, a good thing that I done this. I'm glad I'm doing this stuff because I'm learning a lot in the process. Recognize our arguments, graph output JSON. So it's not an acceptable format by GraphViz now. Module GraphViz has no attribute. No, this is the other one. Usage pip-dep3, HV, Python ALU, silence pass fail, JSON3. So maybe if I do JSON3 here. Then I do dependencies dot JSON. I forgot the need there. I need to figure out how to change the color of this thing because it's almost impossible to see. Yeah, graph output is different. So it's probably not gonna work. And if I just type JSON, it's not gonna work because it doesn't have this output. Or maybe I forgot the space there. Module graph is so same mistake. I think I'm gonna close these things because it's not allowing me to close the files there. I think I can search for how to save. First pip-dep3, pip-tools. Hey man, what's up? I didn't have luck so far. I should figure it out. I tried a couple of things, but it's not working. But at least I think I'm getting close. Yeah, I figure out, I think, actually, I'm not really sure, but I think the problem is not on GraphViz, the problem is on pip-dep3. And it's hitting this line here. If output format not in backend.formats, then it throws this error here. but it makes the file. So I think the problem is with pip-that-tree. So it makes the file, but it's empty. Just working on that import tracker. Seems to work, except it crashed on NumPy. Yeah, but I don't know. The reason why I want to do with graph is because I think it's gonna be difficult to translate the information into a graph if we are able to do it with the sys.map metapath route. But I'm going to study the metapath anyway because it seems like it's very useful. Do you for machine learning stuff? I didn't know that people used it for machine learning, but I saw a couple of videos of people using it. Let me close this thing. Another approach is that it is what I'm trying to do right now is to use pip-that-tree on a script, then save the information somehow or attach it to a variable, then loop through the list or object, and then use graph vis that way. So this also seems like interesting. Here's a graph I generated. Let me open. Dang, that's crazy. That's exactly what I'm looking for. It's really complicated. How did you do this? And this is for the requests library. And then it breaks on the NumPy. I'm gonna save this for sure. Blue is third-party libs, yellow is standard lib, and red is unknown. Can you change the color of the arrows? And obviously, I imagine it's gonna be hard to do that. But what I think would be nice is also change the color of the arrows and have some way of telling like importance, how many times it is called throughout the library. I mean, obviously there's so many ideas to expand this. But it's, to me at least, it's super interesting, this stuff. It's kind of like deep learning in a way, because you are seeing the tree of connections of logic of the computer for the baseline programs. So super interesting. I have a much more detailed mode, but it's kind of a mess to read. Oh, so if you can, send to me. Obviously, I'm very thankful for that. You don't have to do that. So. Isn't datetime a library that is built in on Python? If I'm not mistaken. So maybe the arrows here are in the reverse order, or because I imagine that's the way that you made it, right? It starts on the request and then it chases everything to the bottom. So these ones are the ones from Python that are built in, and then these ones are the other ones we used. Yellow is built in. Yeah, but it's weird because I saw datetime as Unless I'm mistaken, I definitely could be. I ran a command, I don't remember which one was it, but there is a command that shows you the built-in libraries in Python, and then I remember datetime was one of them. Was not on here. I forgot where I put it now. Can depend on other built-in libs. Yeah, that's true. So there might be two datetime things. It was not here as well. Maybe it's here. Yeah, here. Sys.built-in module names. Let me see which ones. I don't remember really well, to be honest. I have to import this. Let's see. Let me do this one. Yeah, so these ones are currently, so math is in here. But yeah, I linked that more detailed graph above. Oh, let me see. God damn. It's almost impossible to read this stuff. But I think there's not a lot, because it is gonna be complex, right? That's the issue. That's crazy. And that's just for the request thing. Can you do one for sklearn? Let me save so it's easier to play around. That's awesome, man. Yeah, I have to put this here as well. Yeah, sklearn is a library for machine learning. There's a third mode, the groups that groups the nodes in the same module together, but they send it. Everything is good for me. Even if it's hard to read, I think it's already like really cool to see that, because you can explore here and just to see the visualization. It's kind of like you're seeing your brain, you know. Seeing the connections of the things. It's much better to me. Maybe if there was a way to increase the size of the letters of the description of the things, and like maximize the size of the description and minimize the size of the arrows, it would be more confusing to see, but it might be better to find out stuff. I don't know how hard it was also for you to do this. I imagine it was really hard. So it might be very difficult to change that stuff. God damn, man. And what's the difference between these versions? What did you change on them? In blocks. Yeah, but this has a lot of stuff. Damn, that's crazy. I don't know how difficult it would be to do that, but I think would be cool to do is if you could do like something that you can select the path and then it shows the arrow of the specific path. Like kind of like Google, but imagine if you could saw the path that Google goes through to find a search for an item. So do that, or you highlight the search what you're searching, and it shows on the graph the arrows get highlighted. But it might be extremely hard to make that. I'm not really sure. Because this is gonna be really tough to read and to understand. But it's already way better than nothing, obviously. Like, way better. I'm interested in the sklearn one also. Because request is not really interesting to me. So if I can that with Graphviz, I need to look into another graphing lib. Pretty sure I can't with Graphviz. Yeah, but yeah, it's a question of how much effort you wanna put right in this stuff. I'm not sure if it's worth it either. Like I can't say. Stuck on styling. Okay. You might have to degrade your Python version. I had this problem when I was trying to install it because the latest version of TensorFlow is up to Python 3.9, I guess, or 3.8. So if you have a higher version of Python, you have to use two different versions. So you can create a virtual environment, install an earlier version of Python, and then alternate between the two. That's what I'm doing right now. I'm using Conda for TensorFlow and the other versions for other things. Yeah. So if you didn't get a warning, I guess it's fine. When I tried to install it, it didn't work. I don't know what to do as well, but you should put this on Stack Overflow. I think you might get points or something like that. Because at least I've never seen this before when I was looking. Seems like nobody did this before. And I think it would be very useful for people that are just starting to learn to code. So let me go back here and I'm gonna put the description. Yellow is built in, just so I don't forget. I think I have to do it on a notebook. Oh. So what name did you give? Import tracker. That's dope, man. There's so many ideas I have with this. It's crazy. Where was I? Let me see. Well, we should all. I can also give you the script for you. Oh yeah, I would be very thankful for that if you can do that. Everything is a bonus for me, obviously. I think it will be cool to also. I'm gonna read the pip-dap3 script as well. Just try to understand how it is searching these libraries. Standard lib feels yellow to me. Let me put this on the Chrome thing. How long did it take you to do this stuff? You're probably very experienced. I'm gonna create a file here with your name. Then I'm gonna copy the code. If your Twitch name, obviously. This is interesting to me. I see this all the time. I don't really know how people use this. The way I saw before is with globals, to set global variables. I'm not really sure how it works. Module input import. Orange import mode. Yeah, this is a lot more advanced than what I can do. Or what not what I can do, but what I'm used to doing. So this returns this class here, this function, I guess. Gets off kv, pretty important, k. It's definitely a lot better than what I can do, that's for sure. Uh, just like there's a bunch of things here that I don't understand. Like I understand. It's kind of like when you know something but you don't really understand it. Know what I mean? It's that's how I feel. It's kind of like I know the letters and stuff, but I don't really understand how it goes together. I don't think I would be able to do this on my own with my current level of skill. Probably I would be able to, but it would be definitely in a whole different way than this. Also here you decide the color. Blue is side packages. So blue is for other ones. Else yellow. So it's not if it's not a side package, it's a built-in package. I don't know what this T means, but I've seen this before. But that's so cool, man. Honestly. Yeah, I'm just trying to look to read first because I'm not sure if I understand everything. So I need to run and then put where do I put the library? Let me try to run it. Do I need to type the library? Oh, no, I get it. So let's do the 0 first. Hmm. By capsule import cannot import module datetime. And how is it save automatically? What's the letter? You told that it doesn't work for some packages, right? Yeah, it's because sklearn has NumPy. That's why it's not working. But we will figure out what is going on. Yeah, this is already a different file from yours. So the problem seems to be on this multi-array thing. That's where the issue is. Then there's another exception here. Turn bootstrap gct import. And this thing is, I think, is from the sys metapath thing. It's from the import function of Python itself, this thing. But still, what I'm doing should be identical to what would happen in normal Python. Just that I save the data to a graph. Yeah, so it must be on this transition, right? You must have to do something with translating the information into graph formats. Importing the NumPy C extensions fail. This error can happen for many reasons, often due to issues with your setup or how NumPy was installed. We have compiled some common reasons and troubleshooting tips at this. How does the file save automatically? It's on graph.gv. I removed my method from the class. In other words, it should be basically identical to its parent class. NumPy still complains. Yeah, you have to be patient with me because I'm not I'm very new to programming, so I don't understand a lot of things. Original error is spy capsule import could not import module datetime. I think the best way to approach this is to see where the fundamental things here are and then try to investigate them. Have you explored the NumPy library directly, the source code? There's also something we can do. I replaced something with sys that is a direct. With a subclass of dict, it does not change any behavior. Something with sys that is a direct of a dict, and it still crashes NumPy. So you're pretty much using the same code as Python, you just changed, I assume this thing here, instead of sys modules, you made it a dictionary of sys modules, and then you attached this. Oh no, this is a different thing. But this part here, right? Do you understand how Python processes the information when it's loading the script or the file into another file? If a dict subclass crashed NumPy. That's really interesting. And why it doesn't crash the other things? We can search this. It's probably going to be on site package NumPy. Obviously. I'm not even going to read this. I'm just going to go through the file there. Um, yeah. NumPy. Yeah, here it is. other stuff works because other stuff does normal stuff. I think the process is first it searches for the library, then it loads the library, and then it attaches to a namespace. That's the 3 steps. But I'm not exactly sure how the process works behind the scenes. Like what's the code that does that exactly? So it must be on the second part that the problem is, because it's not loading and the other ones are loading. So it has to do with the way that the information is formatted somehow. So I assume there is a distinction between the graph format and the usual way NumPy is used. It might be on the parsing of information or something like that. Not something with the graph. And what do you think it is? What do you suspect it is? Crashed before we try to even render the graph. Should not try to import NumPy from its source directory. Exit the NumPy source tree and relaunch your Python interpreter from there. One thing that I think about is to use a try except block. So it skips the NumPy, and then we can see the graph without the NumPy. And then on the exception, just put NumPy there, like somehow. But first I need to understand how this code works, because it's still very abstract in my mind. Did you study anything to do with sys module, or obviously you had to study this because otherwise you wouldn't be able to build it, I assume. But this set here I have to look for. Yeah, that's what I'm saying. And then when you get to NumPy, instead of getting the library, it prints something, or because then you're gonna know that is NumPy there, but there must be a way to solve this problem, right? It's just a matter of trying different ways and keep trying until it gets right. I mean, this already saves me a lot of time. And it's exactly what I wanted as well. Because then you can use this graph and use inspect module to find each one and go to the bottom of it. And you can also see which ones are used most often, so you can create a hierarchy of importance of study. And now have to study the connection, the files themselves, to understand how the relationship is being built. Because just like a neural network, I assume that there might be ways to build the design more efficiently somehow. I don't know, I have to think about it. So I have to spend a bunch of time thinking about this. Like maybe there's a way to connect this stuff with the trees from the neural networks. And then you have the whole graph of the solution, not just from the algorithm of the neural net, but everything to the bottom of Python. And you can create a much better visual representation of what's happening with the flow of the electromagnetic field to become the solution of the data feeding of information. And you can see, then you can compare modules, different modules, and see how much they overlap and how much they don't, and what is happening when you increase the accuracy. I mean, there's a bunch of applications, I think. But it's gonna be very difficult to do this. There's no doubt about it. Let me think about. Let me open up the libraries here. I'm gonna try to select one that doesn't crash. I have a bunch of libraries here. The issue is that a lot of them use NumPy, because NumPy seems to be one of those fundamental libraries that everything uses. But I'm gonna understand this code here, and then I'm gonna try to solve it. Not I'm gonna try, I'm gonna solve it. Really hacky. Here it should work for everything. Yeah, I don't see why not, right? I mean, any problem is solvable, really. It's just a matter of how much effort you're gonna put in. And it's not really clear, but I think this is important enough that it's worth trying. And at least me, I don't know how much experience you have, but I'm already learning a lot from this, a lot. Like there's a bunch of things here that nobody talks about on the tutorials and stuff. And these libraries are built by the best people in the planet, pretty much. So they know what they're doing. So it's kind of like killing two birds with one stone. You build something and you learn a bunch of things along the way. Always return the super call and then never change the arguments. So I don't know how this changes anything. This here? Yeah, I don't understand why you're returning super. Super, from my understanding, is a constructor class, right? When you create a class, you create the init with the attributes of that class, and then you create super when that class inherits another class, and you want to pass the same arguments, if I'm not mistaken. But here you don't have an init, so I assume the super gets the key v from sys modules, right? And you're checking here to see if the first argument of the sys modules starts with this underscore here, because that's probably how libraries are written, if I'm not mistaken. Or maybe that's not correct, but the get method of the parent class. Oh, I get it now. So this super calls get kv, which is here, but this get self kv is from the parent class, which is sys.modules. So the graph had a lot of like JSON. Oh, okay. what is this get frame here? Underscore get frame. Is it a class or a function? Probably function because the way you're calling. But it might be a class also. Gets the execution frame. Execution frame. I have to study that. I don't know what it is. N levels back. I guess execution frame is the context of the code, right? That the thing is going through. What code is? Okay. If import lib not in file name. So if I make too many questions to you and you don't want to answer, it's completely fine. I'm gonna research all of this stuff, but I'm just asking these things because I have no idea. I walk this stack. So I walk this stack up until I get something not coming from import lib, which will most likely be the file the import was in. So I walk this stack up until I get something not coming from import lib. So everything that comes from import lib is not a library. That's what you're saying. So you get the file with the imports, let's say pandas, for example, then you search for that where the file is coming from until you find a file that is another import, which is another library. And if it is a library, it's not gonna have this import lib here in the execution context of the sys modules. Think of a traceback. I'm walking up a traceback until I get the first entry, not from import lib. Yeah. It's just that I don't know exactly in which context this import lib exists, because I never see import lib on actual file names, so I suspect it's something from sys.modules that happens behind the scenes. Behind the scene. And here you're doing plus equals 1 because you want to get the next frame, next level each time. Iteration. If import lib not in file name, break. So if it's not in file name, you break. And find relative path. Relative, forgot an A here. From Python import locations. Import abc calls import lib internally. Import abc, I think I've saw this before. It is from sys.modules, if I'm not mistaken. Calls import lib internally. Yeah, that's what I suspect, which calls more import lib functions, finally landing in my get function. Yeah, still don't think I understand, but it's getting closer, getting better. Part this also calls import lib. In which cases it doesn't call? When it's an actual import, right? Like what? start being syspath. So these are the all possible paths. That path file name. Absolute. So it gets the path of the file name when it gets to a file that has import lib in file name. That doesn't have import lib on file name. Then makes this thing here, relative path. Path else possible paths that append roll path. Then we're making a list of these paths here. I don't understand why relative true is, so I'm gonna search that as well. Oh, this is for later. Is that this is basically a cache imports away. Imports always hits this. If this returns none, it does the actual import. Yeah, I don't really understand what a cache is still. I have to study that. If you add a print file name in that loop, it might help. And I would then recommend testing on something like the random module. So you're saying here, right? Where you were asking for input here? Right. Oh, the first one, module input import. Then mode input mode, which you select these ones. And then I think that those are the true ones. But I'm getting a lot of better. I'm still first time I saw this, I didn't understand much, but now I'm starting to get it. What you did here. I'll be right back. I'm gonna get some energy drink. Basically, Python only loads a module once and stores it in this dict. Loads a module once. So future imports just get it from there. Oh, okay. Yeah, I'll be right back. I stopped here. I think I'm gonna run and try library there. Let's try this one. It doesn't work, I'm gonna try test the random, like you said. I can't print. Oh, 0. Maybe I can make a list of all the ones that don't work and see what's common between them and the ones that work. So it comes from lines 73. Part modules, module. This one. Let me try a different one. So line 73. 0. Line 73 again. I'm gonna try a different one. This one is not gonna work because it has NumPy, but I just want to see the file. So this is a different error than the other ones. Utils are module. I have no idea what utils is, to be honest. These are the libraries or whatever it is that I put here to study because I don't know. Some of these I know what they are, but I want to understand. But a lot of these I have no idea what it is. This check build, for example, I'm not sure. Probably not a library, but I still put it here because I want to understand what it is. I just want to understand everything, to be honest. Understand how everything works. Yeah, but here it's saying that it is important. Importing. And 22. So whenever it hits NumPy, it reads this problem here, multi-array. And when it hits the other ones, it's on line 73, which is import modules. There's too many files. The NumPy has a try except there. Where? Oh, try here from this import multi-array. When it's still hitting this. That's interesting. You should skip, right? And do the accept block. So it probably is working, but it's something hard to do. What does this dot mean? You're making a relative import from multi-array. From this relative import multi-array. Or I think the accept re-raises it. Line 12. Which line? That one calls other things that raise the exception again. NumPy.core multi-array umath import add doctrine implement array function. Could not import module datetime. During handling of the above exception. Line 73 again. Yeah, this line seems to be a problem. Might not be from the line itself, but from something that is attached to this line. And then this bootstrap as well from import lib library. Oh, so this is the library from Python of the sysmodule thing. Yeah, frozen import lib is bootstrap. Except import error from bootstrap. I have never seen this PyCapsule import before. Yeah, me neither. Me neither. How long have you been coding? What's your experience? I also have to search what's this dot here. Yeah, makes sense. Not import module data. Let me try OS. Oops. Oh, OS works. Run graphical. Did you close? No. Oops. I'll close this. Run graph. Source. So this is the graph. Dot graph is dot source source. Where is the source? Here. Add graph lines. Saves on the file, right? I'm not really sure. Yeah, apparently it didn't save here. Let me open this on the Google Chrome thing. This, I'm gonna put this on the favorites as well. Seems useful stuff. So where is the graph saved? Does it have any information here? I need render format, input, output format. It's interesting that this didn't show up for me. There. Yeah, but doesn't show up anything. Maybe it's a problem with my graph is it's not gonna show up. Yeah. Oh here. Oh. So just do this. And that doesn't work. Yeah, you're talking about the exception here, right? But I'm talking about this option here. It didn't show up for me. Error rendering graph async IO. So that's probably it hits this try block here, this except block. This whole thing here. So you only want the G graph, D graph. I think mine hit the accept block there, and it didn't load the graph. I think it's probably because the way that I installed graph is I was having a problem with that before. I don't want the graph code. Oh, all the text. Oh, there we go. Nice, so it works. Damn, feels so dumb. Oh, that's interesting. So I guess he only has 1 hour because OS is on the bottom layer, right? Of the, I think it comes from Python. If not, it's like very doesn't depend on anything. Yeah. Let me try a different one. I also have to think. Uh, Maybe there's a way to reverse the arrow direction because it would be interesting to see the other way around, right? But I guess what we can do is run the thing with the graph and then just get the modules. Yeah, but the modules are not gonna show the direction. That's the problem. Like instead of vivax pointing to OS, OS pointing to vivax. Oh, nice. So this works. Nice. Oh no, but this doesn't work. It's not that what I want. Is the other, like, the direction of the arrow itself. This is just the direction of the graph. But the arrow is still the same. You know what I mean? But it's probably more complicated to change it. Or maybe this arrow here. And now, for some reason, it's crazy. That doesn't work. On line 57, swap importing module import name G. Imported name G. 57. Hmm. I'm gonna run again with the OS just to see. Yeah, it's still the same thing. 59. Okay. Should I redo the changes there? Done. 59. Oh, here. That's the way that it did. So let me think. I don't think I need to change. It's just the arrow here, just like this. Yeah, that should work. Oops. It's not working for some reason. That doesn't work. Does not support reverse arrows. You need to swap the left and right side. Oh. That's interesting. Even though it's on a string. Now apparently it's probably gonna work there. There we go. That's what I'm talking about. But did they really change it or? Yeah, I think that's correct. This shows from the bottom to the top. Yeah. I think I'm gonna try with all of them. But I'm gonna spend a lot of time trying to figure out the NumPy stuff. Because I want this to work with all the graphs. And then maybe we can change the stuff on the future as well. And that's, I mean, there's, yeah, billion ideas to do. Should do stuff with this. And I believe it's gonna help me a lot for sure, studying the libraries, the source code. I can make a file with just a bunch of these graphs, and then I can find a bunch of correlations and try different designs as well, along with different. When I start building machine learning models, I want to connect these things with each other. I'm not sure, but I don't think it's NumPy only. It has to do with this multi-array here. Everything that uses multi-array is gonna fail. And it's not from your file, it's something that import lib uses. So it has something to do with this functionality here. And these overrides, I need to understand what this dot import is. I think it's for relative imports. Oh, so it does use NumPy, matplotlib. Fuck, I don't want to create this. I'll create it another time. A relative import. But I know relative imports when you put the name of the file here. So for example, this, then it's gonna import overrides from this file in the same directory. But if it's only the dot, it imports the whole directory. I'm not really sure. For example, this, I think is saying from this file here, import everything. And this file is in the same directory as the other files. It doesn't go through the system. The system imports. Our current module should be exact. Okay. But what file, if we were not specifying? Any file? because it's just a dot. NumPy the core, multi-array UMath. Is these two things, import lib module, import module, and then the UMath stuff. Line 73. And multi-array. From dot import overrides imports numpy slash overrides dot py. Here, this file here. Line 73 is just an import using a function call instead of the import syntax. And what would be the import syntax? It just imports what input you gave. Yeah, there's also this bootstrap thing here. G cd imports. I mean, something weird is going on, right? If some of the libraries are not working and some do, something has to be. There's something that we can change here that's gonna make it work somehow. Just a matter of understanding what's going on, which is not easy, of course. Import abc arrow import lib dot import underscore module abc. This is the syntax for the index, right? Syntax for the import syntax, you're saying. Yeah, so matplotlib uses numpy. That's the problem, as you said. It comes from the score init file. Maybe if I search picapslow import, and I'm gonna search the other things here. Python. I mean, eventually I'm gonna figure this stuff out. Porter picapslow import cannot import module pyexpan. Userly Python 2.7. Check this. Environment variable. I don't think that's the issue because I can use NumPy without any problems normally. I found that you solved the NumPy issue. Really? Unfortunately, providing a C API for an extension module for more information. Capsule. This subtype of file object represents an opaque value, useful for C extension modules who need to pass an opaque value as a void pointer. Useful for C extensions modules who need to pass an opaque value as a void pointer to Python code, to other C code. So this comes from the Python thing itself, it seems like, from the source code of Python. To make pointers in memory for values. It is often used to make a C function pointer define one module available to other modules. So yeah, that's the use. It creates a C function pointer defining one module available to other modules. So NumPy creates a function pointer in C, so it is available to other modules. And it's probably part of the source code of Python. So the regular import mechanism can be used to access C APIs defined in the dynamically loaded modules. Just add import NumPy to the top of the file and it will ignore it in the graph. But does it show the missing correlation? You know what I mean? So do I erase this or maybe oh, it's not this file, it's on here. So import NumPy. Shows the links to NumPy, but nothing from NumPy itself. Nice. So let's see if it works. God damn. Oh, but this, yeah, this is a way more complex. Do you understand what this is doing? This web page here? Maybe we can hack this thing here using the inspect and create our own stuff. Nice. So matplotlib seems to be way more spread out than request. It uses a bunch of different modules, but they're not really connected with each other. But where is NumPy here? Yeah, it's not showing NumPy. Oh, here, NumPy. Nice. It renders graph.vis. Let me see if I can learn anything from this. So this all this div class here. It's probably gonna be on the console and JavaScript stuff. It is rendered as a SVG. You can generate the same stuff from this Python script if our graph was working. So on your computer, it loads the graph already, and it saves on a file. Generate the same stuff from the Python script. Damn. Yeah, that sucks for me. I need to find a way to solve this. These packages and setting up stuff is really annoying. It's the most annoying part of coding. I don't either. It's probably, I mean, because I don't have the lib folder. And it's not here. Maybe I just have to add here. When I start it with pip install, then the Anaconda finds the path, but then the file doesn't have the formats file. And when I install it directly from Windows, the Anaconda can't find the path. I tried reinstalling and tried installing directly from the site, and I tried installing with pip install and conda install. Then with conda install, it creates the site packages. It installs in the site packages, but it doesn't have the lib file. And when I install it directly, it has the lib file, but then Anaconda can't figure out the path. It's not here. It's here. Where is this thing? Maybe I delete it again. Oh no, here. I have never touched Anaconda. Maybe I can try with a different interpreter. The problem is that I'm using Anaconda because with TensorFlow I can only use my version of Python with Anaconda is 3.8, and then when I tried with 3.10 it didn't work, the TensorFlow, because you have to install CUDA or something like that, which is a graphical something to do calculations on with sklearn for machine learning. And another normal interpreter that I have is 3.10. So it doesn't work. And it says that it's missing on this backend, is missing the formats file when I try to do with pip-dep3 directly. But the graph seems to work. That's the strange part. It doesn't work when I use it with pip-dep3. So I thought that might be a mistake with pip-dep3. But here it doesn't seem to work either, so. And what is a dgraph? Maybe I can create a script that uses this dgraph and create the graph in another way, and then maybe it will work. Direction graph. Graph is syntax. Let's try this one. So now, let me see. In the end here, 1, 2. Try import graph dot graph as source. What if I put this stuff here? I have to display node ng. Language to create graphs. So it's different than Python? Or it's in Python and maybe I have to do it after. Yeah, error rendering graph. Async IO. Oh, I could just try to change things here. Oh no, doesn't work. The source here. So obviously the problem is this name here. Can you remove the try exam? But then I feel like it's not gonna run, right? It's hitting this block and then it's not running this part here. So the problem has to be here. And it has to be with this async IO. Which is probably another library that GraphViz uses to do asynchronous functions. But then it gives the code anyway, which is the source, right? Raw graph code and doesn't show anything. Then it shows the graph, which is, I think is the source, which is this here, which is lines dot append, which is the information of the connection of them. It will crash, but we will see the error better. So I'm gonna comment out here this stuff. Yeah, it didn't show anything now. So it didn't crash and it didn't show anything, which is very strange. Comes with Python. Yeah, the problem has to be with GraphViz. It's something with GraphViz in my computer. Yeah, but I'll figure it out eventually. Like, it's not a problem. Only the code in the try block? I'm not sure if I know how to do this. Maybe like this works? It doesn't work. Oh, if I clear this out. Should put source here. I don't think I'm gonna inspect this. It's worth it, more worth it to try to understand the way that the thing works. It's gonna be a dictionary. Maybe there's another library instead of graphics that I can do this with. Or maybe I can create my own as well. Maybe I can inspect the source code of graphics and do my own. Remove the try everything, accept and unidentified. So remove this, remove the try, okay, everything and accept, and then unidentified. Ah, there we go. Line 1. Do you want to walk through this? So import graph is giving me a mistake. So the library is not working. Let me know if there's any of these lines you want to see. So here's probably the file. Artistic. Oh, we'll open real quick. So I think this file right here, right? That's the last one. Get running loop and set running loop. So apparently it stops here. In a new file, to me, or on the other file. There's so many files here. Where is the other file? I think I closed accidentally. I'm afraid of losing this code here. I think I'm gonna do another file just to test this stuff. Relax. True. Because I'm definitely gonna be using this a lot. I'm gonna try import async AO here. It's probably not gonna hit that. Yeah, so it's not importing even here. Base events, same line. From async AO import get running loop. Maybe I can search that on Google. Or DuckDuckGo, I should say. Yeah. But it's weird that maybe I've never used an asynchronous function, right? That's might be why I never ran into this problem. I'm gonna be right back. maybe I can do async def here. Maybe, I'm not sure if this works. Can you try and import async.io in a different script just to rule out that it is not something the script has? Yeah, of course. Oh, so I have the code saved here, the original one. Yeah, now it runs fine. That's interesting. I'm gonna close all these files for now, so it's easier to know what I'm doing. It should revert all its changes. I think it's on the graph. I'm pretty sure it's a graph is the problem. It has to do with the formats, probably. Side packages. Graph is. Does your graph is has a bin folder? Like, how did you install it? Using Git or? I think I'm gonna try to put this bin file inside of here and see if anything changes. There's also this lib file. I'm not sure if it does anything. Hopefully it does something. I'm not worried though if it doesn't work. Like, whatever. Your stuff is already really enough. Like, now it's just a matter of optimizing and trying to figure out if there's better ways. The main idea I have for now is try to improve on this. Is so I'm able to click on different parts of the graph and highlight arrows. Because on those really complicated graphs, it's going to be very useful. And the other idea is to create a hierarchy of importance of how often libraries are called given an application. To see which ones are the core pieces, let's say. I think those are the two main ideas I have now. Poetry. I have no idea what that is. Let me try to run this again. Yeah, still the same thing. Kind of like pip, Python package manager. Or that chocolate stuff from Anaconda, I think. I'm not sure. I used chocolate before, but I have no idea what it is as well. I think it's a package package manager, like you said. Like you said, that poetry is wraps around pip, managing virtual environments and stuff for you. Oh, good. Good to know.
All right.
The same thing.
So we're going to practice using Dot, which is a program that comes with the GraphViz package, to draw finite state machines. So specifically, we're going to recreate some figures from the Beasley and Cartoonen finite state morphology book from chapter 1, and then view those figures, create PDFs from those along with it. So it's got two states. Example, finite state machine versus generally would mean that you only have the side and one for the output side. This example only has you'd just be working with finite state automata. There is, as far as I know, if you ever figure that out. Okay, and how do I exit what? Oh, like if you type dot and it does that? Yeah, so it's waiting for input, so hit Control D. Or Control C. Control C works. Yeah, Control D would be telling it end of file. If that doesn't work, do Control C. Okay, so we're going to start by creating a text file. Call it whatever you want. I would call mine foo.text, but I already did that, so make sure I remove it first. Or foo.dot. Okay. Okay. All right, so now I've got my editor open, whatever editor I'm most comfortable using, which for me is Emacs. And now we have to think, do I remember how to create something, create a basic drawing in Dot? If I do, that's great. If I don't, I go and open the Dot manual. That's probably not going to work. Oh, for me, I guess it did. Otherwise, I would type graphviz.manual. And I get to the helpful documentation for a drawing with Dot that's 40 pages long. And oh, right here I noticed something that's useful, sort of. It tells me how to create an output file. We'll get to that in a bit. However, in the modern age that we live in, you will almost never have to create PS files. Back 20 years ago, before PDF was really a thing, or at least not a popular thing, PS files were much more in vogue. But here we go. Here's the part we want. So we're going to create something called digraph. What's with the die? Well, that's directional. So we're going to create a directional graph. We're going to give it a name, call it whatever I want. Let's call this Beasley figure 1. Okay, and I'm going to create state on that goes to off. I'm going to terminate the line with a semicolon, and then I'm going to say off goes to on, and similarly have a semicolon. Can I go back up once I've typed something? I'm in a text editor, so yes, I can go back up and down. If you are using cat, then you probably can't go back. But I would not recommend using cat as a text editor. It can be done, but it's fairly masochistic. All right.
Interesting.
Okay, so created this file. I've saved it. And now I'm going to see if my system administrator or me has installed a program called xdot. If you are on a Mac instead of on a Linux server, and if you have installed dot by going to the GraphViz webpage and downloading the whole package and running the installer, it is quite likely that you have a program on your computer that if you double-click on that file, assuming it doesn't open it in Word, which it might try to do, because dot is also the extension of Microsoft Word template files, but if you tell it not to open it in Microsoft Word, then it'll open it up. There's a program very similar to xdot that's built in when you install GraphViz on a Mac. But this gets us to why we SSH in with graphics forwarding. So I'm going to say xdot foo.dot. And it didn't work because presumably I forgot to log in with the -SSH -y. So let's try that again. I'll exit. And yep, I didn't use -y. So -y or -x. I'm being lazy and not authenticating. So now x.foo.dot.
The first person on Twitch doing Python. Really? That sounds strange. Python's it is supposedly one of the most used languages, along with JavaScript. No, really? It's interesting that these different engines here give different representations as well of the same graph, the same structure. Yeah, each one has their own thing, right? I don't know, people. There's so many people on the planet, it's kind of crazy. And I think most people on Twitch stream game dev stuff, probably. And people have different incentives to stream as well. Different algos to place the nodes. Yeah, so that's what we have to study, right? How to use those graphs. Like how does engines, what are the algos from the engines? Because then we can implement our own stuff. The better one. Maybe that I can use inspect to see here. Yeah, but it's not gonna show me. Oh, here's drop domino. Circle dot. Also. Now the thing is I suck at this. I don't have much experience doing this. I know it's somewhere here, but no, I want to figure out what the algorithm is doing to create a graph. Like, because at least I get this D graph, right, from your code. Then with this output here, if I manage to put this output, to get this output, and run through this engine, like, if I can copy the algorithm from the site on the dot, and see how it's translating this input into the output there, then I can play around with the code and see if there's different implementations that I can do, and maybe add more features into it. Use this graphics. Yeah, that's the thing that we have to. I have to figure out what's wrong with my graphics and why it's not working. And it's strange that it works through here, but it doesn't work through the PyCharm interpreter. So here, obviously, the execution is going to be different because it uses the web browser and probably JavaScript or something like that, and goes through a different path to execute. And the graph is probably located. It's probably everything different, right? Only other person I think doing Python is George Hotz. Yeah, that dude is a genius, man. I'm far from him. I think he broke an iPhone, right? Apple, a long time ago. What is this site? Now making autonomous cars. Yeah. Do this 5 head, 6 head. Source code of Graphis. The issue is I should have this stuff here if I download it, right? Because there is a file on site packages called Graphis here. So it should be this code here. Jupyter integration. Python wrapper just wraps that. No, it was learning smart contracts. I did some initial classes on that build space stuff. I don't know if you heard it. And then I was gonna study, but there's so many things that I need to study. Is unbelievable. I was gonna do this crypto zombie thing here. But the more I search for these things, the list keeps increasing of things that I have to study. But it's good. It's part of the process. Maybe I should try to download all this stuff. And instead of looking from here, I can look from here. Oops. I think it's downloading here. If this works. Yeah, I tried to download using this link here, but it didn't work. It's because when I downloaded it using the link directly from Windows, PyCharm wasn't recognizing the path, even though I entered there using their interpreter and things like that. Because I have it here on program files, C program files, Graphis. Then I've put this on the path for the environment systems, environment variables. Then I attach this to the file system here, settings, interpreters, show all, select this one, add this one. Then I add it, but it didn't work when I added. It didn't recognize for some reason. Installs graph is not the Python wrapper. You're not reverse emerging that any day soon. It installs graph is not the Python wrapper. So you're saying on top of this stuff, I need to install the Python wrapper and put it on the same file. It is just a command line tool that there happens to be a Python library for. Mm. What's happened here? So I'm gonna try to do what you're telling me to do. Hmm. I think I'm gonna try to uninstall everything and install it like this. Oh, this is the same file as before, the same page. This is is a bitch, man. I hate this stuff. Usually it's the hardest thing for me. The configuration of things. But it's also something you probably get better with time as well. I can just run pip install with this. Or conda install. Choco install. Do you recommend Linux more than Windows? I tried to use Linux sometime, but I found it really hard. Yeah, the problem is that if you use Linux, then the way I did it, I created a virtual machine with Kali Linux. I think it's Kali Linux, the name. And then I had to switch between operating systems, and that was really annoying. And I don't want to have Linux on my main system because some apps give a bunch of problems. But maybe I should do that. Yeah. I suspect it's like one of those things that is harder on the beginning because you have to get used to always dealing with a bunch of stuff that comes from using Linux, but after you get used to it, then it's much better. And those are getting rarer every day. Yeah. It's just a big commitment, to switch. I'll think about it. Maybe I'll switch. But then you have to reboot the system as well, right? To format everything and save on a hard drive. I have an external hard drive, so I could do that. Hmm. Yeah, I'm not really playing games anymore anyway. For now, at least. Maybe sometime in the future I'll come back, but the main objective is artificial intelligence. So I think I'm gonna uninstall all this stuff. So from what I understand that you're saying, I need to install a pip install graphviz first, then install this package. The pip install version is the Python wrapper for the normal package. Then I put this package on the environment variables, and this one is gonna recognize this one. It doesn't. At least when I did it, it doesn't. I tried both conda install and pip install. Which one do you think I should download first? I'm excluded from this. But maybe I'm doing things wrong as well. I'm not really sure. I can try both ways. So here, I can install it from here. I'm even gonna install it again. I had it here. The GTG's gotta go. If that's the case, no worries. I'm very thankful for your help, man. Really helped me a lot. And I'm gonna spend a bunch of time trying to make this better as well. Hopefully I can. Oh, maybe that's the problem. I was making the wrong installation. Maybe it's Python graphics instead. Pip install graphics. Hopefully this works. It is installed here, but I suspect it's gonna give me the same problem because there's no formats here. Let me check the environment variables. It is here. Maybe then I have to try to put it there again, so it recognizes the same problem. So I'm gonna try to put it here. Interpreter, base, show all. This. I'll remove this one. I think I'm gonna reopen stuff just to see if it makes any difference. still loading the libraries. Doesn't work. I'm gonna try to add from the Anaconda now, the lib, see if what happens. Async.io. Side packages, graphics. I suspect it's not gonna work, but hopefully there's a small chance that it does. Oh, this is the vivax show file. It didn't work. So I think what I'm gonna try to do is run this code here without anything else on the file. And I'm gonna erase this stuff. Here there's no source there in the end. I'll close this file. Oh yeah, but then I need, well, I'm gonna erase this. I'll run this. Line 5, source. So it's in the wrapper. Wrapper function, args. Missing one source, so I have to put a source here. So let me see on the original file. Source. I can put a string maybe. It's gonna be a string. So I can put this one here. Maybe I should get the OS stuff because it's easier. There's less information. So I'm gonna put it here. I'm not sure if this is gonna work, but Oops. That's probably not gonna work, but just to test this. Oh, it does work. Oh. Oops. So it created a file here. Nice. Source.gv. Hmm. I'm gonna search for how to build a graph is dot source. Following are 30 code examples for showing how to use graphics.tgraph. These examples are extracted from open source projects. Maybe if I do graphics.tgraph instead. Invalid arguments. So I need to change this stuff so the argument works. For a source project, you can vote up the ones you like to vote on. May check out the render repair set by. May also want to check available functions classes of the module graph is. No, there's so many tabs. Source graph, the graph. If path is none, path OS show entries, GV format date now. So this is the path. Self, I don't know if you with temporary directory self.tempter, g equals dgraph, format png, graph attributes, spylines, ordo, node attributes, shape, plain text, label lock b. For node in self.tree, image equals self bar, chart known, node pair is not known. Yeah, I don't understand what this node means. Maybe a video will help more. We're gonna be right back.
So today's question is how
grab some stuff, go to the bathroom, and close this window a bit because it's reflecting on the window.
Question is, how can
the computer.
I create a directed graph in Python? That's exactly what we're going to be doing today. We only need two libraries to do this. They're both really easy to install with pip. We're using Linux as always, and I'm really eager to bring you this video today because it's going to allow us to do some basic image segmentation using graph cuts in just a couple of videos time. So let's get started. So before we get started coding, we should ask, is there any additional tools or libraries we need in order to achieve what we want to do? And the answer today is yes. We're actually going to need two modules or libraries, whatever you want to call them, and that is matplotlib and one called networkx. So all we need to do is pip install networkx, and I'm already using it, so that's kind of fine. Requirement already satisfied. And the other one we need that you probably already have is matplotlib. matplotlib. We're going to pip install that, and the...
Let me install this library that don't think I have. Pip install network X, I think.
Network X.
Already satisfied.
I'm already using it, so that's kind of fine. Requirement already satisfied. And the other one we need that you probably already have is matplotlib. Matplotlib, we're going to pip install that, and the requirement's already satisfied, of course, because I already have that. So once we've done this, what I'm going to do is create a empty Python file. Now, I'm just going to be really lazy, and I'm going to call it test2.py. I've already got test.py. We could call it something else, you can call it whatever you want, but I'm just going to call it that. And then we can open up, I'm going to use Sublime, and we're going to open up test2.py, which is just going to be an empty script, and it's actually opened an old Django project of mine, but don't worry about any of that, we just care about what's in this file. So what we want to do then is we want to import the two libraries we just installed. So we want to import network X as NX. Don't do that, please. I knew it was going to do that. NX. And we want to import matplotlib.pyplot, which we've probably used before, as PLT. So that's kind of the first thing we want to do. So we've now installed everything we need, and we've also imported into our Python script everything we need. And what we can do just to make sure there's no issues is we want to just Python script without any errors.
So he's not using graph.graphviz.
Or G, and this is going to hold, just makes more sense. Although I prefer vertices. Right. So what we want to do now is, like I said, we want to start building out this graph. And we can do that in multiple ways, because the library has, the documentation basically says, you can create nodes and you can create edges. We want both. So what we're actually going to do is create our own nodes, and then the edges are going to be generated automatically from us, from tuples. So the way we're going to, hopefully I didn't confuse you there. So the way we're going to do this is we're going to say add edges from, and what we're saying is we're going to add edges automatically from these nodes that we're generating. And this is going to hold a list, and it's going to be a list of tuples, and each tuple is just going to have a pair of nodes. So we've got one node A and one node B. Hopefully you can see that. Camera's over here. So we've got node A and a node B, and they're going to be connected by an edge. Okay, so that's clear. So we could start with that, but let's make it a little bit more complex. And we're going to have another pair, and that's going to be A and C. And then we could also connect either B to C or C to B. I'll do C to B. So that way we've got A to B, A to C, and C to B. Now something else that's worth noting here is, by default there won't be any directions or arrows on the graph, but if there were, then the arrows would point from A to B, and then A to C, and C to B, which we'll see in just a moment. So that's kind of the first bit. So as we mentioned before, we're going to take...
So I'm going to take the code from the side here, and I'm going to try to transform the things that he's saying. But yeah, so it seems that the nodes are, color equals red, then OS, they're all here. OS, color equals yellow. So this specifies the color. And then the rank direction is up top there. Yeah, but
minimalistic approach to displaying this graph. All we want to do is display the nodes, display the edges, display the labels, and then actually display the graph. So but one thing we have to do before we do that is define how our nodes, so A, B, and C, are going to look in this graph. Because right now, we haven't said anything. We don't know where, where's A, B, and C going to go. It's just random. And what this library network X actually does for us, it gives us a bunch of options of how we can display these nodes, and it will basically do a sort of pseudo automatic matter. We've only got a few nodes, but as you get more nodes, and I'm just going to copy and paste it into here. You can actually think that we want to do now. Let me just look to my left hand side. We want actually let's put G in here. So we want G the second half of the video. So let's just keep it simple. It's kind of a dictionary or a set if you've worked with dictionaries and sets. So even if you can have multiple, you can have messy 1, 2, 3, 4, 5, 6, 7, no, 9 lines of code, so less than 10 lines of code, including the imports, which is quite nice. And if we execute the script now, and A towards C, and then C towards B. Now if we
yeah, what I'm gonna do is I'm gonna try to understand how the graph works, and then I'm gonna take the output from the other function, which is gonna be lost somewhere here. It's gonna be this thing here. So I'm gonna try to use this dgraph object here to try to use another script with this object that creates a graph separately, and this might work, I guess.
Okay, so today we're going to take a look at Graphviz, and what Graphviz is a graphic visualization software. So what you can do with Graphviz is you can take nodes, you can define your nodes, you can define your edges, and what Graphviz does for you is it generates from those nodes and edges a picture that you can look at visually. And the reason why you want to do that is because sometimes when you're looking at data, it's kind of hard to see the relationships between your data points. You can have it so that you can explain to other people how certain things interact in your program or how certain things interact in just nature in general. Anyways, let's actually get started with this. Most likely when you use Graphviz, you're going to make one of the graphs, either a directed graph or an undirected graph. And the difference between the two is fairly simple. A directed graph has directed edges, and undirected graph doesn't have directed edges, and that's pretty much it. So for example, if I want to make an undirected graph, I would type graph and then give it some name. I'm just going to call it G. And we are going to define a node in relation in this graph. So let's say we have a node A, and this A is connected to B. So there we go. We have our first relation A is connected to B by an undirected edge. Then we're going to close this, and
Let me copy the thing first again. So thing here. Because this is what gets returned from that function there. From the other one. Let me run this real quick. Yeah, there has no commas or anything like that. Yeah, it's exactly like this. Okay.
we're going to save our Graphviz file. So now, how do we actually render out the picture? And we render out that picture using the dot command. So we're going to type dot, followed by the argument t, png, and I'm specifying t.png because I want to make a png file. If you want to make any other format, look at the man page and see the appropriate command for that file format. And we have to specify the Graphviz data file. So our Graphviz data file is g.gv, and we are going to output to a file called file.png. Now, when we do that, we're going to use our image viewer to view that file. So we're going to look at file.png, and as you can see, here,
another thing that I have to change is the extension of the file, which is probably going to be gv instead of pi on this vivax2 thing. Yeah, but then I'm going to have to learn how to code on a different language.
here we have our graph. We have A, which is connected to B, and B is connected to A. And that is the first graph that you made. Congratulations. Now, to make a directed graph, we can go in here and we can change the graph to digraph. Now, digraph, I think, stands for directional graph or directed graph. And to make a directed edge, we are going to basically change this character here to this greater than sign. And now what we're telling graph is A is connected to B by this directed edge. And if we save that and we run that same command again, we can see now that A is connected to B, and there's a clear flow from A to B instead of just being undirected. Now, we can also have multiple nodes. So, for example, if we want, we can have A be connected to C, and then we can have B being connected to C also. And if we run that, we see that now we have A is connected to B, and then B is connected to C, and A is also connected to C. Now, here's the thing. We see here that A is connected to B, and A is also connected to C. We can actually avoid typing out multiple lines like this by having A connect to B and C on a single line. You have a shorthand for defining which nodes are connected to which nodes. So we can say A is going to be connected to both B and C. And if we save that and we generate our file again, we see that we get the same end graph, but we had to write one less line. And this is actually really convenient. And you can also do this on both sides. Let's say you want to make a graph where nodes A, B, and C are connected to nodes D, E, and F. We can do that on one line in Graphviz. So in Graphviz, to do that, to make that graph, all we type is A.
Oh, so now it works.
And then we're going to make a direction.
Nice. So it's probably just the extension that was incorrect. The graph. So now it shows up there. So I'm gonna do this and I'm gonna run and see what happens. So source is the graph part. So all I have to do is look up how to do save. How to save a
directional relation with this to
Graphviz file.
And if we make this file, as you can see, a Graphviz connected all of these things for us automatically. So instead of having to define a connection for each node, we can just use that shorthand to connect multiple nodes together. Okay, now that we have this graph on our screen, we see that it's not really that impressive. And it's not impressive because it's all the same color, and the only difference between the nodes are their basic contents, like what they're called is A, B, C, D, E, F. We can actually style these nodes. Now, to style these nodes, we have to specify a node style, and we specify a node style like this. We type node, and then we are going to set the style to be filled, and we're going to set the color of these nodes to be yellow. So if we save this and run our program again, we see that the nodes in our graph are all yellow now. We can also do the same for the edges. So if we want, we can style these edges to be, let's make them dotted, and we're going to set their color to be red.
I'm gonna try to do this as well. Do this. Run again. 0. Yeah, so he's not running the graph itself.
And now we have a graph that has yellow nodes.
It would be much better if I was able to do the graphics stuff instead of saving to a file. Because if I can, then I can try to do a bunch of things there. I can learn how the graphics works, and I can style it in a different way in a bunch of different files. Then I can use specific style formattings to get different visualizations of things.
Has dotted edges which are directional. Now we can also edit the shape of our nodes. So for example, we can say that the shape of our nodes is going to be square. And if we run this, we see that our nodes are square now. Now, here's the thing. You can actually style these nodes individually, and I'm going to make this a little smaller so you guys can see the whole thing without it being squished like that. So in this graph, we can specify an individual node, and we can specify a style for this individual node. So have A, and I want to style this A node, and I want to set its color to be red. I can specify color is red. If we run this, we see that now individually A is red. We can do the same for B if you want. We can say B color is blue. And you can just go on forever with this kind of styling. I think you can even have, you can even use HTML styling in the styles, so you can build really sophisticated looking nodes. Okay,
oh yeah, before I forget, I'm gonna close all this stuff. And I'm gonna focus on just trying to figure out how to do this work. How to download this, because it's not working. Hopefully I can make this happen. Yeah, this I can close as well. This is the graph-based documentation. Spectre facilitates the creation and rendering of graph descriptions in the dot language of the graph-based graph drawing software, a string repo from Python. Create a graph object, assemble the graph by adding nodes and edges, and retrieve its source code string. Save the source code to a file and render it with the GraphViz installation of your system. Use the view option method to directly inspect the resulting. Well, one thing I can do is change the interpreter and see if it works. No, but then I can't use the sklearn thing, which is a problem. From now as Python notebooks. to render the generated dot. Oh, but this spectra runs under Python 3.6. Oh yeah, but mine is 3.8, so it should work. Make sure that the directory containing the dot executable is on your system's path. Anaconda, see the conda forge package, which should automatically conda install. Maybe that's the problem. I'm going to delete the ones I have and do it again. From scratch and see if I can make it happen. Graph this. Delete this. Delete this one. I'm gonna go into environment variables, path, edit, remove this from here. See path here. Delete. So I think I'm gonna close this. Go on the forge package. Python graph this. So maybe this is the problem. I'm using conda interpreter, but I'm installing with pip install. And I should use conda install /c. This command there, the first one. Okay, so let me keep following this tutorial. If you get a question whether to run or save the file, choose run. Otherwise, save it and then run it by clicking or double clicking on it. You see this dialog. Click yes if you see this dialog. So I'm just gonna do what it's telling me to do. Next, agree. Current user. Next. Click install. Start any applications or command prompts where you want to use graphics. Versions you have now successfully installed graphics. Try restarting your computer if you still have problems running graphics. Maybe that's the problem as well. Abbreviated installation instructions recommended for users with installation experience. And maybe I didn't install properly as well. Now let me try to run it. Now it's giving me a different mistake. There's no attribute source. And this is not source any source. Let's try it like this. At least it's giving me a different mistake now. Remove pydot and install pydot plus. So I'm gonna try the commands from the guy. Pip install pydot. Pydot plus. Already satisfied. Sudo apt-get install graphics. I guess this is for Linux. It is not installed. Oops. Set the bin folder, environment path variable, and then it worked. Solution installs the 0.82 version, but works for cars, which was a problem for me. If you're using Conda, then run the following Conda install C and Conda Gravis. Be sure though to run Conda command as admin to avoid privileged permissions. Maybe if I do it from here, Conda. Oh, it's 32 my system. Let me check this. Maybe I'm installing the wrong version. That's the problem. I thought it was 64. No, it says 64 bits. X64. But maybe Anaconda is 32. Maybe I have the wrong version of Anaconda. Let me try this thing here. Yes. I'm gonna restart this. I'll check if it's on the environment variables. Currently it's not here. Yeah, it's not here either. So probably shouldn't work. It worked. Nice. It worked. Finally. I found a demo that is like what we wanted. Let's learn this framework and see what amount of JS we remember. Yeah, no worries, man. I'm gonna study my ass off and try to do this. I managed to make it work, man. I think I was doing something wrong with... I used Conda and then apparently it worked. I don't want to speak too soon because I don't know if it saves the right way. Yes, it worked. Nice. Nice. Now it saves as a source GV file. And then it created the graph this here. Yeah, let's go. Oh, I think I can delete this. Maybe. Yeah, this is the file that I made. So I'm not really sure how to change the name of the file. But yeah, that's not a big deal. It's super easy to change after the file is saved. Let me see this stuff you shared with me. Dynamic data neighborhood highlight. This example shows the power of the data set. Once a node is clicked, all nodes are grayed out except for the first and second order connected nodes. This example will show how you can determine the order of connection per node as well as applying individual styling to the nodes based on whether or not they are connected to the selected node. The code doing the highlighting only takes about 1 millisecond. The rest of the time is the redrawing of the network. 9,000 edges, over 9,000. Nice. So this is a JS framework. Yeah, it's highlighting. And then when I do this, it shows the graph. Exactly what you were saying, just that it is JS, so time to somehow connect those. Yeah. And we need the arrows as well. So we need to connect this with with the graph piece stuff. I think it's on source that you find JavaScript stuff. But I'm not sure if it's possible to see the source code of the thing. Maybe they have documentation somewhere. Dynamic data. Yeah, I think it's gonna be easier to search for this and the name here. Viz network. Really? Provide the source code. I think it's on here that you're saying. Maybe it's just a GitHub part. Not found. Documentation. Nice. There we go. Yeah, I found it here. And then you showed me example.js. How did you find this stuff, man? Is it just searching while I tried to solve that other stuff? But then this is different than graph is, right? Or you might, it's probably the same thing, but a different application. It uses dot here, dot language. So it's similar, different style. Nice. I'm trying to think about all the things I can do with this. Totally different in how you program it. But the engine isn't the same. I saw that there is dots there. Maybe there is different engines as well. Node styles, HTML, icon images. Yeah, I'm a total noob, so it's more difficult for me because I have more stuff to learn. But I'll devote as much time as necessary until I'm able to get it done and understand how it works. The thing is, I have a lot of ideas on when it comes to more of the mathematical and physical aspects of things and how to connect things, but my detail understanding is really poor. So I have a better understanding of the overall macro vision of how I want things to go, but when it comes to actually the programming, I still don't have a lot of experience. So I need to balance these things out because otherwise I just get lost on too many ideas. I'm gonna grab more drink there. And this is the repo, I guess, for the network. npm. So it uses Node.js. Creating a wave with edges. So maybe if there is a way to parse from the GraphViz structure to this one, then it might be easier. But I'm not sure if it is. Yeah. Let me close these windows. I'm gonna close all the ones that I'm not using right now. Probably close these ones as well. Derivatives.
And so I'm going to say
No studies, just so I can clean up space to focus on this shit. So yeah, change from this to the other one. You can modify the Python script to produce output I can easily parse into this. Exactly. I think that's the best way to do it. Because otherwise, we're gonna have to understand the whole language and how things work, and then it's gonna take a long ass time. I'll be right back, real quick. Just graph this stuff. I'm gonna close all this stuff since it worked already. And this is the other stuff. You change any settings you want while the network is initializing in the VS data set. Set options and set data. Finally, you can destroy the network and completely reinitialize it. Dataset change the data while it's loaded and initialized. Change one's color dynamic. Yeah, but this doesn't show how to build anything. So this is the code here. I think I'm gonna copy this code into this thing here. There's so many files here. I think I can delete this shoe. Then I'm gonna download this code as a zip. I'm gonna see what's up with this. So it seems like it's JS, Node.js code, which I don't know a lot, but I have some experience doing things with Node.js, which is very similar to Python. It's all the same shit, to be honest. Just small differences between things. Now I'm gonna open this on the PyCharm stuff. Then I hope this doesn't break the graph this thing. Struct. I can close this. Get logger config. So here's the documentation network. It's all HTML. So I guess these are not the scripts themselves. Oh, I think I got it now. It's because this is built on the websites, so it's probably gonna be, yeah. It's gonna be HTML and JS and CSS. Or maybe I should watch videos about this as well. Dot parser. A shit ton of files here. So I guess this is the structure of the nodes for each graph. This is the graph file here. That's my file. Scripts. As layout, siege network unless supplied explicitly. Intention here should make the layout stable. That it should keep the layout the same on every screenshot. So this is interesting. Document value. So I'm gonna search for how to parse graph V's into V's network. And I think I can do it here because I already downloaded this. Yeah, sure. Yeah, thank you. I don't know what to say. Uh, you're really helping me a lot for no reason. So thank you. I'm gonna keep studying anyway while you try to do it. Because I want to understand how it works as well. And it's very useful. I mean, I think this is really useful thing, really useful thing. I'm not really sure why nobody did this before. It seems like a very obvious thing to do. And it will make a lot easier to study for sure. I remember thinking about there definitely is a correlation between these and neural networks. For sure. Absolutely. Because all of what this is a connection of nodes that performs calculations following a logic through inputs. That's the connection between libraries. And that's what a network is doing as well, neural network. But the difference is neural networks have backpropagation. And they adjust to the inputs. And libraries are more static. They don't change when you use them. There is just a collection of instructions, right? So it seems like it's almost like a tree where the libraries are the roots and they don't change much, and then the neural network are the leaves that are adapting to the wind. I think it makes sense. And there's probably a way to connect both of these things, and having a visual representation I think is very useful to understand the framework and the flow of information. But I might be wrong about this as well. It might be just a waste of time. Who knows? Network is a visualization to display networks, a network consisting of nodes and edges. This visualization is easy to use and supports custom shapes, styles, colors, sizes, images, and more. The network visualization works smooth. Any modern browser. Install npm, install Viz network. Example. This example loading a network is shown below. More examples can be found in the examples there. So this creates an HTML with the style my network, style header body, div script. So this is the node object, new viz.dataset. Dataset assumes the class that is going to contain the nodes. An array of nodes. Create an array with edges. So instead of from 1 to 3, you can do from the function there. Let me find. Oh, now it seems this is giving me a problem for some reason. Let's see if it still runs. Yeah, nice. It works. Nice. That's cool. Source GV. There we go. Oh yeah, before I forget, I'm gonna run this format plot for a scalar. Delete this file. I'm also gonna create a folder here for graphs deep, where I'm gonna store these files here. Oops. Scalar. Damn. Multiprocessing. Most likely due to a circular import. So I'm gonna try the same solution that you did there. Let's see if it works. Hopefully it does. Yeah, it doesn't. Mm. It's crazy how many packages exist here. It's breaking the same thing that I was breaking before, but this time doesn't work. I'll close all these files. Oops. So it's a dictionary.
Porting a module is the way to gain access to the code inside it. Module is just some code in a single file. In this example, we have a print statement, a variable x, and a function named say hi as code. Code is in a file named module1.py. Within the same directory as module1.py, we have another file main.py. In main.py, we have one line of code to import module1. Note that the file name without the .py extension is the module name. Now, let's execute the main.py file using the Python interpreter. You're seeing the output of the print statement. So simply importing the module executes the code in the module line by line. First, it creates a module object somewhere in the memory. Then the module name is saved as a key in the current module's global namespace dictionary. Value corresponding to this module name will be the address of the new module object. This is the same as if we declare any other variable within the file using the assignment operator. If you check the type of module1 variable, it shows as module type. Module objects are instances of the module type class defined in the types module. Like with any other variables in Python, we can get the memory address of the module object using the id function. We can even create a new module object ourselves by passing the module name and a docstring to module type. Like other variables, you can also create an alias to the module object. Both my_mod and module1 will be references to the same object in memory. The import statement itself supports creating custom names for the module. In the next example, we are declaring a global variable x and a function my_func. Within the function, we are printing the variable dunder file, which we didn't declare. After importing this module in another file, we can see our global variable x and function my_func among the attributes of this module object. All the variables and functions that we declare at the global scope within module1 are available as module object attributes after the import. Python also creates a few other variables like dunder file, dunder name, etc. Within module1, we can use them directly since they are available as global variables. All such symbols are stored in a dictionary of the module1 object. You can access those values by directly using this dunder dict attribute. Python also provides an easier way to access these attributes using the module name.attribute name syntax. The undername attribute will have the module name as its value. Module name is the same as the file name without the .py extension. The under file attribute will have the absolute path of the module file. You can call the function declared in module 1 using the dot syntax. If you look at the module name in the attributes dictionary, you will get the function object. Using parentheses, you can execute the function object. Note that all the Python modules are not necessarily written in Python. Some are written in compiled languages like C or C++ for better performance. Here, the socket module is a regular Python file, but math is not. Python exposes its import system through the metapath attribute of the sys module. Metapath is a list of objects. To understand what these objects are, we need to know about finders and loaders.
I have an idea. Sync.io. Same problem. 75. What is a bootstrap GCD import?
Python's import system has two conceptual objects called finder and loader. A finder's job is to locate a module, and a loader's job is to load that module. In practice, a finder is a class that has an instance method findSpec, and a loader is a class that has a load module instance method. What metapath shows is a list of finders. So all of those objects implement the findSpec method. Some objects implement both finder and loader. Such an object is called an importer. Based on the name of the objects themselves, you will be able to tell that the first two are importers and the third one is just finder. Next, let's try using these methods ourselves. Here, I'm saving the built-in importer object in the variable importer. Built-in importer is an importer for built-in modules. Built-in modules are different from the ones in the standard library. Built-in modules are modules that are compiled into the Python interpreter. Built-in module names attribute of the sys module returns a tuple of all such built-in module names. Since an importer is a finder, we can call the findSpec method on it and pass the string itertools to it. The findSpec method returns a module spec object. This object has information on which loader to use. Since built-in importer is also a loader, we get the same object itself. Then, you can call the load module method on the loader. This returns the actual module object. In the case of importers, both finder and loader are the same object. Next, let's see what happens if we use built-in importer to load a non-built-in module. It simply returns none. Next, let's use the pathfinder. Pathfinder is the one that looks for Python modules under different file system paths. The list of paths it will look for Python modules is stored in sys.path. This list is initialized on program startup, and the first item in this list will be your current directory from which you run the file using the Python interpreter. Next, let's call findSpec on this pathfinder object. It returns a module spec with information on which loader to use to load the socket module. Here, the name of the loader that we should use is source file loader. It also has the path to the socket module file. Note that here the loader is not the same pathfinder object. We can get the module object by calling load module on this source file loader. Python also sets this module spec object as the value of the underspec attribute of the module. Next, let's see the whole process of importing a module in action. When Python executes the import statement, it first checks in a global cache of already loaded modules. This cache is just a dictionary with the module name as keys and module object as values. If the module is present in this cache, it's returned immediately. If not, Python's import protocol is invoked involving the previously mentioned finders and loaders. Loader creates the module object in memory. Then, an entry is added to the global cache. Sys.modules is the dictionary that maps the module names to modules that have already been loaded. Then,
Yeah, that's what I was thinking. On the first file, the first lines here now. Class things types of sys modules. That's why it has K and V here. K is the name and V is the address, I guess. Did it save anything? No, okay. Yeah, so I'm gonna put V here. Object. But it doesn't show what V is, unfortunately. Let me put this here. Zero. It's just OS.
In our current module's namespace, we get the name module1 as a reference to the module object.
So that's what
What happens
global
when you
is.
delete module1?
Globals.
It simply removes the reference in our global namespace. It doesn't delete the module object. This behavior is the same for any variable in Python. So if you import the module again, the module code is not compiled and executed again. You get a reference to the existing module object. Another interesting thing is that if there is an entry in sys.modules, no further checks are performed. Here, I'm adding an entry for my underscore test. Its value is not a module object, it's a function. Then, if I do try to import it, it completes successfully. Checking with the type function also shows that it's a function. Suppose we wanted to reload a module. We just saw when the module is imported for the first time, Python compiles and executes the module code and creates a module object. The mapping of already loaded modules are stored in sys.modules. If we delete the module name, it only deletes the reference in our current module's global namespace. The module object and its entry in sys.modules persist. This is not what we wanted. Another option is to delete the mapping stored in sys.modules. Remember, this also only deletes the reference to module object stored in the sys.modules dictionary, not the actual object. Now, if you import the module again, Python will first look in sys.modules. Since it's not there, it will compile and execute the module code to create a new module object. So we were able to achieve what we wanted. But there is one problem with this approach. If some other module in our project had imported the module, it will still have reference to the old module object. That's why for such use cases, you should use the reload function provided by the import lib module. Instead of creating a new module object, reload will mutate the existing object in place. So all other modules that have reference to this module object will be able to see the changes. Import lib also provides many other useful functions. The import module function can be used to manually import a module without using the import statement.
Let me see which imports you did. Sys path lib, import default text, import lib, multiprocessing. I put it there. So I think the issues here are both with cyclical imports and with async IO. That's why some libraries are not working. Do this. Scalar 1. Circular imports. Yeah, cannot import name context from partially initialized module. Multiprocessing. And the problem is with import lib.bootstrap. But it should be hitting this condition. It prints the file. because it doesn't have import lib in file name. Then it breaks, then passes here. Path lib, path file name, absolute. So I guess it runs until this line here. Importing multiprocessing. Let me see if I change this line here. See what it does. Doesn't give any format. Try to print here. See what this is. It's probably gonna break there. I'm gonna add a break here so it doesn't go through the other stuff. Let me do something here. It doesn't work. If I do it like this. Oh, it's probably not gonna work, so. I don't see the difference between this. If the file doesn't have port lead, oh, it has to be and I guess. I can also do different. It doesn't work. Because K is multiprocessing. Is not the thing. All modules.add. Where is all modules here? It's here. Multiprocessing as well. Scene.add. I'm gonna figure this shit out eventually. It doesn't hit this line. Uh, uh, Open up the curtains, sir. So I think I'm getting close to figuring this shit out, but for some reason, so basically this super.getKV is appending to the sys module all the imported names. And then the ones that are giving me a mistake is the frozen lib and the import lib bootstrap. And I guess it comes from class dict sub. So I have to understand how the class sys modules works. I'm trying to understand where this all modules is useful here. I think it's storing all modules. Is storing the names on all modules and passing to the sys modules class with this super get kv. I'm not sure. Oh, here, all modules.add imported name G. Line is here. Not sure if it's seeing this line.
Find spec will return the module spec for the specified module. Next, we will see how to import a module without using the import statement. We will compile and execute the source code ourselves. Here, we have a file with one function definition. This will be the module that we will import. Within our main file, we store a name and path to the module file in two variables. I'm just setting a random value as module name. Usually, it will be the file name of the module without .py. Next, we create a module object using the module type class. Then we set the dunder file attribute of this module object to our module's absolute file system path, just like how Python does it. Then, we add the entry within the sys.modules cache. The key is the module name and the value is the module object. Next, we open the module file and read its entire content. Then, we compile this source code using the built-in compile function. Do import socket as my_socket. The symbol name in the current namespace will be my_socket instead of socket. Collections is a package and socket is a module. Once you import a package or module, we get a module object just like what we saw till now. The only difference is that, for a package, this module object will have the dunder path attribute set to its directory in which the package code resides. Here, this is a directory. For modules, the dunder path
I think I'm better off searching for the stuff that I actually want. I already typed this here.
Hey everyone, and welcome to another Python tutorial. In this video, you're going to learn how to load Python modules dynamically from your Python applications, and this can be handy if you're trying to build a plugin system, or basically want to make your application configurable so that based on a string setting, your application will load a different module and then execute it as a plugin. So I know this sounds very abstract, so I want to show you a simple example here. Imagine you're working on an application that includes different plugins that can be dynamically activated. So for example, maybe you have something like this in there where you can go from plugins, import my plugin, and then we've imported that module, and we can do something interesting with it. So we can call an example function and do something with that. Now, this is pretty static, right? If I want to import a different module here.
Real Python. They have really good articles here. At least the one that I read was really good.
Here, maybe I want to import my plugin too. If I want to do that, I have to change the Python code. You want to make it so that your user can just change a configuration setting, and then you will dynamically import a different class. Or maybe the user can even add new plugins to a
file. Have you made any progress on the JS stuff?
That maybe you didn't ship with the application, and it could still be dynamically loaded. So the question here is, how do you modify this code?
I'm going to figure out how to do it for NumPy before to change your code. Then I'm going to work on the JS stuff. Because to me, the most important library is sklearn, so I think that the priority is to make your code work with for that. And I think I already have an idea of what's going on. It's definitely on the cyclical imports and on this bootstrap import. It's probably a different path that the import library goes through, the import lib. I remember seeing a video about this or reading an article that sometimes when you do cyclical imports, it doesn't work because one file is trying to load something from the other, but the other file is not loaded yet or something like that. So I think that's the problem that is going on here. So when you call sysmodules equals dict sysmodules, you can't find the import because the file hasn't loaded yet, because there is a cyclical import.
You can do something like this, right? Instead of actually using the import keyword here, how can you make it so that I can, this is pseudocode now, but imagine this was fully fleshed out. Imagine we wanted to do something like this, and then do this, right? Where we want to import the actual plugin that's specified in this config variable. Now, if I try and run this code, this wouldn't work because it would always try to import plugin name. And really, plugin name would be a string like this that would then say my plugin or plugin 2.0 or something like that. How can we do this? Certainly, we can't do it with the import keyword, but there's still a way to implement this functionality. And this can be highly useful if you're trying to build an application that is user configurable, or if you imagine, instead of this plugin name coming from a config variable, what if we just looked into a specific folder and then tried to load those files? So how do we make this work? This is what this tutorial is about. So let's get started. What I'm going to do first is I'm going to start fleshing out the application. So I've already created an empty folder here that I can work with. This is where we're going to put this example plugin system application. And right now this folder is empty. So what I'm going to do is I'm going to create a bunch of files. I'm going to create a file that's called app.py. This is just our example entry point for the app. And then we're going to create a new folder for all of the plugins. And I can see here we have this app.py and the plugins folder. And then inside plugins, I'm going to create, I'm just going to create a file called 1py. That's plugin number 1. I'm going to save that. And then I'm also going to create another plugin that is plugin number 2.
Yeah, the issue is that those libraries require asynchronous importing, I'm guessing. But the code is not running with asynchronous importing. Not import name contents from partially initialized module most likely due to a circular import. Let me check this stuff you posted here. Damn, that's crazy. Oh, so you're doing on one of those sites here. There we go. Nice. This is already insane. It's much, much better than the initial one. You can also move the things here. I assume this is for the request. Ring rag. Really, yeah, requests. No, nice. Damn, that's crazy. That's actually insanely good. I mean, honestly, think about how much better this is to study them, to look at all the files one by one and try to visualize in your head where stuff is coming from. Let me study the code you did, and so there's the CSS. Dynamic. Oops. I have to think about the names of the files. This code was hacked together from the example code. But did you do the things manually? Well, I think it's really nice. The result is, I mean, it looks so good. And the fact that you can move things and highlight different things. I mean, this one is 10,000 times better than the other one. To visualize it. But I'll have to think more about, because there's definitely a lot of applications for this. So dynamic HTML and this CSS, I'm gonna put it. And then the JavaScript. I want to figure out if there's a way to parse the other one, the other result. Yeah, whatever. Into this one. After I figure out how to make it work for the sklearn stuff. Nice. You code so fast, man. It's crazy. Did you change the JS or all the files? Let me copy here first. I have to go to the bathroom real quick. I think that, at least for me, what I'm gonna focus is first make it work with NumPy and the other libraries. Then I think the next step is to connect, to find a way to run this recursively. So you have all the connections between things. But I have to think more about this. It feels like there's something here, but I can't quite grasp it yet. But given some time to think about it and reflect, there's probably some really cool stuff that is possible to do. Then I mean, if you wanna go absolutely insane, then what you can do is the same process for C++ and then C, and then assembly, and then the compiler, and then you just create a giant graph of all the connections of everything. And then you can attach labels to each language and see where they deviate on the nodes. And then you can abstract that from that the logic of the computer. And then you can build a full loop with the machine learning stuff. So you create a giant game tree that connects everything. And then the final step would be to make it so that when you run a program, it shows the connection on the graph of the flow of information. Kind of like electricity. But then that's like pretty much impossible. It would take probably a team of people and a bunch of time, I guess. And thousands of lines of code. But I suspect that this is a geometrical object that is a self-closing, is a loop. It's gonna be a loop. And it's gonna close on itself. When it has a geometry. And yeah. Because here what we're seeing is the logic of logic of space-time. And the arrows determine the flow of the electromagnetic field. And this geometrical object determines the connection of that space-time. So it's kind of like a network that maps space-time through the electromagnetic field. And it's probably going to have similar patterns because everything follows a fractal pattern. But the thing is, there's a lot of missing information as well, because here is just showing the imported libraries and is not showing the classes and functions between them, within them. So, but that would be insanely hard to do, I guess, where you have all the classes and all the functions connected to all the libraries. And then you can see the full picture of the tree of the geometrical infrastructure of the language. Because a computer language is just like a language, a normal language. It's logic connected through space-time. And that network adapts itself given the circumstances of the space-time based on a flow of the electromagnetic field, which is the links of the arrows between the nodes. I guess, but I could be wrong, of course. Now I'm gonna add this to the... Oh, nice. I saw, I clicked on there. I'm just copying everything, just to make sure that I didn't miss anything.
And when you look at this folder now, it looks like this, right? So we have app.py, that's the entry point for our applications, the main file. And we have the plugins folder, and there are a bunch of plugins in there. And now the question is, okay, well, how do we make it so that I can just, based on a string setting, can just go in and load these plugin files? So we're going to build up a very simple plugin system here. And we're going to start by fleshing out one of the plugins. We're actually fleshing out both of these plugins. And the way I imagine these plugins would work, they would just have a high-level class that always follows the same naming scheme. And we're just going to make it so, for demonstration purposes, we're going to make it so that we can pass a bunch of arguments here. And then this is just going to print out some info here, so we have something to play with. So I'm just going to print out whatever gets passed in here, so we can make sure passing around arguments actually works. And then we're going to have a method foo that let's call this something else. Let's call this execute, and then we'll have the self parameter a and b. And now this is just going to return a plus b. And then we're going to copy and paste this for the plugin number 2, and here we're actually going to subtract, right? So you see what I did here? I created these two plugins, 1 and 2, and they're both just modules that contain a top-level class that's called plugin. And then we have an init method and an execute method.
I mean, one interesting experiment that I can think about it off the top of my head now would be to somehow abstract this geometry here. Of course, we can move the geometry and change the arrows, but the connections, look how cool this is. Like somehow abstract the geometry and then create a new neural network with the same infrastructure of connections. And then instead of running the libraries, you run different networks for each thing. Yeah, and then you can make the first one, which is the baseline, be the input, and the other ones take each one has an activation function, and then you put the gradient descent based on the flow of the arrows. And the ones that are, but it would have to be the other way around, because the output has to be the library that it starts. So it has to be the request, the output. Yeah, it could be this way. Then these ones are the input. Each input goes to the network. Then if it's not the end, the output is considered to be a hidden layer. It takes an activation function and then gets to the output. And it might result on interesting things, because if you get applications that follow the same logic of the libraries you're trying to use, there might be some connection there. Okay, let me load. Oh, it's not loading. Oh, it did. It just takes more time. This one is much bigger as well. Is there a way to increase the size of this thing? No, it doesn't work. Oh, now it's gone. So I guess maybe the div that should be bigger. I'm gonna keep researching how to do the stuff work.
That does two different things. So this here is plugin number one. Let's add a little doc string here, just to make sure you can see what's going on. And we're going to do the same thing over there, right? And now, of course, the interesting part is, well, what's going to happen? Let's make sure it's also lints clean. So now the interesting part, of course, is what's going to happen in app.py. Like, how can we dynamically import these modules? And well, of course, I could go from plugins, import 1, 2, and then, well, let's just print them out and see if this works. Make sure this works. So here, I'm just going to call Python on app.py. And you can see here, well, of course, it successfully imported these modules, and we were able to print out the module. And then, the string here, or it gives you a non-keyword-based interface, just a function-based interface to Python's import system or module import. Make sure the quotes here look exactly the same. So reference to them, and now we're going to flush out this this plugin system a little bit more. So typically, and this is this is where this part comes in. And this is why I've named these classes in exactly the same way and gave them the same run this app import statement to seamlessly switch between these two plugins, and it would do different things.
Maybe just cyclical. Yeah. All right, so
import circular air. So, all right. Hi everybody, this is Sam with Python Basics, and we need to talk about some air handling. So, all right, in the past 2 weeks, have had this come up twice, so I've decided that now's the time to talk about it. So, circular air handling of importing a module. So, all right, super, super, super very important. And this was the exact same problem. 2 different modules, two different scenarios. So, string. All right. So look at that. So we can't. So what the issue was is read online post. Actually, no, I'm sorry. It was a comment on the video. Somebody was looking for letter.ascii, and they were getting a circular error. And then a tutoring student was trying to import Pygame, and it was giving them their error. And after the second one, I knew exactly where to look. Super, super, super important. Don't use the same name. So, all right. It will fail. So, that you're wanting to do, but do not.
Just a second. Imports are pretty straightforward, really. Just remember the following. Imports are executable statements. They execute when the running program reaches the light line. The module is not in sys.modules, then an import creates the new module entry in sysmodules. Then it executes the code in the module. It does not return control to the calling module until the execution has completed. If a module does exist in sysmodules, then the import simply returns that module whether or not it has completed executing. That is the reason why cyclic imports may return modules which appear to be partly empty. If a module does exist in sysmodules, then an import simply returns that module whether or not it has completed executing. That is the reason why cyclic imports may return modules which appear to be partly empty. Finally, the executing script runs in a module named main, importing the script under its own module in module related. Cyclically imports terminate, but you need to be careful not to use cyclical imported modules during module initialization. And this doesn't solve anything. This module is not meant to be directly imported. It has been designed such that it can be bootstrapped into Python as an implementation of import. As such, it requires the injection of specific modules and attributes in order to work. One should use importlib as the public-facing version of this module. So the issue here is that I don't know where is the thing there? Where is the bootstrap coming from? It doesn't print anything. Module. Import module. So this is the function. It receives the name and a package. So maybe if I put this on a try except block. Try. Might be the easiest way to solve this. Ta-da. Hopefully it worked. There we go. That's what I'm talking about. And it shows multiprocessing. Nice. So it works now. So now I have to think about how to transform this into the other type of graph. And it's not really that complicated as sklearn. Uses joblib, login, decimal, pprint, pydoc, multiprocessing, copy, time it, scipy, args, gc, socket selectors. The thing that's weird is that this is not showing all the files from sklearn. Because it should be showing all the processes as well. That's the problem. So even before I start working on translated both graphs, I'm gonna, and because it's gonna be really difficult to translate this graph that is on GraphViz format to the other dynamic one. And here, let me see, side packages, sklearn. Yeah, it should be showing all these files here. So, but let me see the init. The photo, the picture doesn't show any of these functions here because it's only showing the imports. Check build base clone. I'm not even sure if it's showing that. I think it's just showing these ones. I'm gonna open up on the other one so it's easier to see. For me, unfortunately, I can't show the two screens at the same time. So this doesn't show here. Maybe it gets from the get config. It's also not showing numpy. So I assume it's cutting out a bunch of imports that it should be showing because I did the try except block. Or maybe it's the setup module. Import seasonal OS. Yeah, it's not showing any of these packages here. See on the config file. Blah blah. Part OS, context manager. So assume this is not exactly what I want. I think I'm gonna close this as well. This is the GitHub for the Viz stuff. I think I can close this, I guess, since my thing is working all. And I already put this on favorite. And I'm probably gonna close this one as well.
Hi everyone. In this brief tutorial, I will show you how to check package dependencies in Python. If you have ever tried to install Python modules,
Just a sec. Yeah, I think I'll have to take a break here to see some stuff. But I will come back shortly. And it's good that I'm gonna rest a little bit. And I wanna solve this stuff. So I'm probably gonna stay a lot more time today. It's good that I'm learning a bunch of stuff. So what I want to achieve is not necessarily this, even though it's a lot closer than I was when I started. But ideally is something that allows me to see the connection between all of these things here. And the issue is that these inits are empty. Yeah, but here, for example, there are a bunch of imports. And this is a part of the SK library, so maybe I can make a loop through a library that checks all the files. And then from then, I can run this vivax script and get the dependencies of those files. Because I want to create a geometrical object that represents the library itself against all the other libraries. Yeah, here use a SciPy. Import Python. I guess I'm gonna learn a bunch of stuff from doing this. I think I already know how to loop through files in a folder. So that's probably the best way. Then instead of passing the module as an input here, I can get the file name. The init of the file name. Well, maybe the import, because it's gonna be all these things are gonna be a file. So I can do sklearn dot all of this in a loop. And then I can see all the imports that all of them use. So first I make the connection. I need to make a graph that connects sklearn to all of this. Kind of like the request one. Not this one, this one. So instead it's gonna be sklearn here in the middle. Then from this one is gonna have the connection to all the files in the sklearn module. And then for each file is gonna have the dependencies that each one has. And that way I can check how everything is connected. Yeah, that's the next step. So I'll take a break and then I'll come back soon. See you.